Hello men and women of science, this is Mr. Cochrane here with the third video on writing names and formulas, and this time we're going to focus on just the basics of binary covalent compounds. Before beginning this video, make sure you watch the first two videos on ionic compounds. Make sure that you have a notebook with you so that you can take great notes, and make sure that you have your periodic table. It will be helpful to you if you can recognize the difference between ionic compounds and binary covalent compounds. As we said before, ionic compounds always start with a metal or ammonium. Binary covalent compounds are made up of two nonmetals. In an ionic compound, the charges determine our formula, but in a binary covalent compound, you'll see prefixes that tell us what the formula is. In an ionic compound, you just name the ions. In a binary compound, the formula tells you what prefixes to use, so let's get started here. Remember that ionic compounds start with a metal or ammonium, and you'll find those here on your periodic table, or NH4. Covalent compounds are made entirely of nonmetals, and here those are highlighted on your periodic table. We'll be using prefixes for naming binary covalent compounds, and the first one is mono. Mono is a little bit unique in that we only use mono with the second element of a binary compound, never with the first. The remaining prefixes are di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So 1 through 10, those are our prefixes. If you don't have those written in your notebook, write those in now, because we'll need them for naming binary covalent compounds. Remember, binary covalent compounds will contain two nonmetals. We name them using those prefixes we just talked about, and all binary compounds, regardless of whether they're ionic or covalent, will end in three letters, I, D, E. Let's start with this compound, NO3. Is it covalent or is it ionic? Well, let's look and see. Does it start with a metal or a nonmetal? Nitrogen happens to be a nonmetal, and that means that's a covalent compound. So we'll use prefixes to name this compound. Let's do it. There's one nitrogen here, which would usually indicate that we'll use mono, but it's the first element, so we're not going to use it. We're just going to say nitrogen. And there's 3 oxygen. The prefix for 3 is tri, and oxygen, we're going to change the name to end in those 3 letters, IDE. So this is simply nitrogen trioxide. Our next example, is it ionic or covalent? We're going to look at the first element. The first element is carbon, and carbon happens to be a nonmetal. That means this is a covalent compound. So we're going to use prefixes to name this compound also. There's 2 carbon here, so we're going to use the prefix di and say dicarbon. There's 6 chlorine, so we're going to use the prefix hexa. And remember, we're going to change chlorine to chloride, so this compound is called dicarbon hexachloride. Our next example, we have Na2S. Is it covalent or ionic? Well, you'll find that sodium on the periodic table happens to be a metal, and therefore this is an ionic compound, and it's really important to recognize that we will not use prefixes to name ionic compounds. So let's just name this as we should. The first element is sodium, has only 1 charge, so we don't use a Roman numeral. S is sulfide ion, so we just call this sodium sulfide. So let's get some practice in here. For each formula, write the correct name. Go ahead and write these formulas into your notebook and their names next to them. Pause the video, and then in a moment you can start it again and I'll reveal the correct names. Pause the video now. So here's the correct names for these formulas. Notice that when we have 2 nonmetals, again, we use prefixes to say what the formula is, and if it starts with a metal, we do not use prefixes. All right, now let's get some practice in with writing binary covalent formulas. Here's the awesome thing. The prefixes tell us the formulas. If there's no prefixes in the name, then it's an ionic compound, and you can see the previous videos on how to write those formulas. Here we go. Let's write the formula for carbon tetrafluoride. You'll notice right away I see a prefix here. That tells me that this is a binary covalent compound, and I don't need to worry about charges. The name tells me the formula. If you just see carbon, that means we have one carbon. Tetrafluoride means 4 fluorides, so the formula of carbon tetrafluoride is CF4. Pretty simple. Let's do another one. This is dinitrogen pentoxide. The di in dinitrogen tells me I have 2 nitrogens, so I write N2. The pent in pentoxide tells me I have 5 oxides, so the formula of dinitrogen pentoxide is N2O5. A third example here, I have aluminum iodide, and you'll notice right away there's no prefixes in that formula, and it starts with a metal. That means that this is an ionic compound, and to write the formula correctly, the charges must balance. Talked about that in the previous 2 videos. Aluminum is 3 plus, iodide is 1 minus. Those charges don't balance to 0, so I'm going to need another couple iodide here, and that gives me a net charge of plus 3 and a net charge of minus 3. The charges balance out to 0, and the formula is Ali3. So now time for some practice. Write each name into your notebook and then write the correct formulas. After you pause this video, and then when you restart the video, you can check to see if you've done the work correctly. Remember, if you don't have prefixes in the name, it's an ionic compound, and you're going to need to look up the charges to write those formulas correctly. Pause the video now. Okay, here's the correct formulas for those names. Go ahead and check your work and make sure that you have the correct subscripts for each item. And if you have questions, go back and look through these videos again, or bring your work in to share with your teacher. This is Mr. Cochrane signing off.